Okay, so let's discuss the one-way ANOVA, yeah, in more detail through problem set example. Okay, let's go back to the earlier example concerning the marketing manager case. Yeah, suppose that you are a marketing manager for a personal computer company. Yeah, and the company uses to sell computer to different universities. Yeah, for the pricing decisions, you want to in the context of applying uniform pricing, you want to investigate whether the average students monthly spending, yeah, of university A, B, and C are similar or not. Yeah. So here you want to decide whether students in university A, B, and C has this similar average monthly spending or not. Yeah, if the average monthly spending are similar, then you can apply the uniform pricing scheme. But otherwise, you have to apply differentiated pricing scheme. Yeah. So the null hypothesis is the average students monthly spending in university A, yeah, equals to B, yeah, the average students monthly spending in university B, and the average students monthly spending in university C. And the alternative hypothesis is not all of the average students monthly spending in university A, B, and C are similar. Yeah. Okay. So okay, this is the sample data set. Yeah. So from university A, we pick several respondents. In this case, we pick 5 respondents. Yeah. Okay, the first respondent states that the monthly spending is 1.4 million, the second one 1.5, and so on. University B, the first respondent states that it's 1.3 million respondents. The second respondent wants 4.4 monthly spending, and so on and so on. Yeah, so that is the sample profile, data profile. Yeah, in operationalizing the ANOVA, we can also apply the 6 steps critical value approach in hypothesis testing. Yeah, the first step is stating the null hypothesis and the alternative hypothesis. Yeah, for a hypothesis null, all the means value of the average monthly spending are similar. Yeah, in all universities. Yeah, in university A, B, and C. Yeah, university 1, 2, and 3. And the alternative one is not all average value of means average value of monthly spending are equal. Yeah, and then the second part is yeah, in the problem state, it is stated that we have to differentiate at the level significant at the significance level of 0.05. The second steps is, you know, choose the level of significance, number of groups, and the sample size. Here the level of significance is pretty much clear. 0.05. Number of groups, yeah, number of populations that we want to compare is 3. Yeah, once university A, B, and C, then groups number is 3, and the sample size n. Yeah, from in a sample size 1 we have 5 respondents. In sample 2 we have 5 respondents, and in the third sample we have 5 respondents. Then in total we have 15 respondents for the value of the n. And then the third step is determine the appropriate statistics, yeah, test statistics. Since we try to compare the means among 3 or more different populations, we pick ANOVA. Yeah. Okay, let's go. And then okay, yeah, in all hypothesis testings that we learned, the principle is, you know, we try to calculate the test statistics and compare it to the critical value and see whether the calculated test statistics lies within the region of rejections and non-rejections. It's also the same case also applies in here in ANOVA. the fourth step is determine the critical values that divide the rejections and the non-rejections regions. Yeah. So here, yeah, in ANOVA we use the F table. Yeah, and how to locate it? We have two different column name, and we have the column name and then also the row name. Yeah, the column name is the numerator and the row name is the denominator. To locate it for the numerator, yeah, is the degree of freedom, I believe, is for the among group variation C minus 1. C, the number group is 3, 3 minus 1 is 2, then we 1 and 2. Yeah, so we locate the column, yeah, in the second column. Yeah, and then for the denominator, yeah, we use this formula, n minus c. N is total number of respondents, yeah, 15, minus number of group 12. Then we put, yeah, we locate the value in the 12th row, and then we have the 3.8.9. Yeah, 3.89. Yeah, and this will be the F critical value. Yeah, so here using the F table, we have the F critical value of 3.89, and then the next step is to locate or to calculate the value of test statistics. Yeah, if it lies in the non-rejection, then we accept the null hypothesis. If it lies in the region of rejection, then reject. And how to calculate the test statistics? Of course, we discussed in the previous video. We will use F statistics, which in principle, yeah, using this formula, yeah, which is F statistics in principle is comparison between the among group variations and within group variation. And and we have to, remark or put an eye to each of the variable and then see what variable are required in order to go to F statistic. Here we can see that we need the grand mean, yeah, the grand mean value, and then the sample mean of each group, yeah, in order to calculate the among group variation of SSA. Yeah, n is the number of value of for each group. Yeah, so we have to calculate the sample mean of group and then grand mean, and also we have to have the how many respondents are there in a group. I think we have that already. And then for calculating within the group variations with the mean value of each group and also the values of the group. Yeah. So in calculating, we go leftward. Yeah. So from this and then go this and then go this. Yeah. From this side, go this and this. Okay. Let's first calculate the this variable. Yeah. The sample mean of group J. Yeah. It's really easy. Yeah. Basically, for uni C, yeah, of course, the sample means is 1.3 plus million plus 1.6 plus 1.6 plus 2.2 plus 2.5 divided by the number of data 1, 2, 3, 4, 5. Yeah, so which equals to the sample mean of group 3 is 1.82 million. It's also similar with uni B. We calculate the means for group B, 1.3 plus 1.4 plus 1.6 plus 2.2 plus 2.6 divided by 5 equals to 1.82. Then we have the sample mean of group 2. This is also similar with sample of for group 3 or for uni E. And then the second, after we have the sample mean of each group, yeah, then we have to calculate the grand mean. What is the grand mean? Grand mean is simply, make a summation of all the values, yes, 1.4, yeah, and then divide it by the total number of the respondents. Yeah, so here 1.4 plus 1.5 plus 1.6 plus 1, 2, 3, 2.5 plus 1.3, 1.4, so on until 2.5, and then divided by the total number of respondents, which is 15. And then here, yeah, 1.4, yeah, 1.4 divided by plus 1.5 plus 1.7. Yeah, we in principle we make a summations of all the values and then divide it by the total number of respondents, and then we got the value of 1.82. 84. All right. And then after we have the sample mean of each group, and then we have the grand mean, then we calculate. Yeah, we go back to the formula. We have the sample mean of each group and the grand mean. Then we can calculate the among group variation, right? Among group variations is, calculated with this formula, and technically, so we have the value of the mean value of each group, and then the grand mean value, and then what we do is like this. This is the number of respondent in each group multiplied by the mean value of each group minus the grand mean. So this is for the first group 5. We have 5 respondents. Multiply the mean of the first group 1.880, minus the grand mean minus 1.84, and then we make a square here. This is for the first group. For the second group, we have 5 respondents also. We put 5, and then the mean value of group 2 is 1.822 minus grand mean, and then we make a summation of all of them, and then the end result of the SSA, or among group variation, is 12 billion. Okay, now we have all calculated the among group variations, and how to calculate the within group variations. The within group variations is basically we make summations of the difference between each of the value within group with the within group sample. Technically we do this way. So 1.4, so and then we square it here. So 1.4 minus 1.880. Look, 1.4 minus 1.880, and then we square it. And then the second component 1.5 minus 1.880, square it, and so on until the last component 2.5 minus 1.880, and then we square it. We do it for all the 3 groups. For group 1, and then for group 2, and then group 3, and then we make a summation out of it, all of it, and then the end result of the within group variations is 3.46, I think, 4 trillion. And then after that, after we have the the among group and within group variations, then we apply. So we apply it to the formula. The SSA, we have 12 billion, and then divided by the number of group minus 1, divided by 3 minus 1, which equals to 6 billion. And for the within group variations, we have 3. SSW, we have 3.464, calculated previously, divided by total number of samples minus the number of group, which equals to this value, 288 trillion. And then the F-stats is simply calculate, make a ratio, or simply dividing the MSA with the MSW value. So 6 billion divided by 288 something trillion, which equals to 0.0207. So we have the test statistic value of 0.0207. And then we come to the 6th step, which is comparing the test statistics and the F critical value. State the statistical decisions and managerial conclusions. We have determined that F critical value is 3.89, and then after calculating the F statistics, we have a value of 0.02, and then we locate that 0.02 is located at the left side of the critical value, which is here. Then we can state that because the F statistical value, or the calculated statistic 0.0208 is located within the region of non-rejection, thus the null hypothesis that states that whether the mean monthly spending of students in University A and B and C cannot be rejected. Yeah, it's not rejected. Yeah, so that is the technical example, technical calculation example of ANOVA. I think it's not that difficult. Huh? Okay, I think that's for me. See you in the course. Yeah, bye bye.